Removal of zinc using sugarcane, done by Teh Lin Lin, Tong Yingxuan, and You Zhiwei Matthew.
Only a small percentage of water is drinkable. However, if it were to be clean, it would bring about many benefits. The environment has been polluted by many heavy metals such as zinc, which is extremely toxic and is known to cause many health complications in a person's body. Therefore, we need a more economical absorbent, which is described as being more abundant in nature. In other words, sugarcane, which is widely available in Thailand. We can thus use this amount and recycle it to remove zinc in polluted waters. The concentration of zinc in the waters of the Mekong River must be lowered to an amount which would conform to the WHO standard in litres, which is 77.110 microgram per litre.
Firstly, we have to carry out the pre-treatment of sugarcane. The used sugarcane is recovered from sugarcane, which has been used to generate sugarcane juice. The squashed sugarcane was then dried using the drying oven. The sugarcane must be fully dried to prevent the growth of mold. And to compare the concentration of zinc in water, a standard curve has to be prepared. Understanding the Beer-Lambert's law is important in ultraviolet visible spectrometric analysis. The Beer-Lambert's law states that adsorbance is equal to molar adsorptivity times concentration of the solution times the path length of the curvette. The standard curve will show the adsorbance rate versus the concentration of the zinc solution. This is the standard curve. The process to make zinc-zincon reagent is as follows from step 1 to 6. This process of making this reagent is stable for 12 hours. The sugarcane pulp was extracted and we started to experiment the different amounts of sugarcane to test for the adsorbance of sugarcane for zinc. The different amount of sugarcane is then placed in the respective beakers. The sugarcane has to be fully submerged into the sugarcane solution for a period of 30 minutes, after which we wait for the reaction to occur and carry out the ultraviolet spectrometry test. After 30 minutes of leaving the sugarcane in the beakers, for every setup, extract 0.1 ml of the solution using micropipettes, ejecting it into a test tube. Then, as for each test tube, add 3.0 ml of zinc-zincon reagent and dilute it to 10 milliliters. After which, shake the test tube and ensure that the purplish-blue complex is uniform. Fill 3/4 of a curvette with distilled water and place it in the UV visible spectrometer for a baseline scan at 620 nanometers. Understanding the Beer-Lambert's law is important in ultraviolet visible spectrometric analysis. The Beer-Lambert's law states that adsorbance is equal to molar adsorptivity times concentration of the solution times the path length of the curvette. The standard curve will show the adsorbance rate versus the concentration of the zinc solution. From our results, it is apparent that when more sugarcane is added into the zinc sulfate solution, the adsorbance value decreases. Therefore, more zinc 2+ is adsorbed by the sugarcane.
Despite the fact that the calculations can be done, as the Zn2+ concentration still present in the solutions was too high, there were many deviations using the Beer-Lambert law. According to the adsorbance curve, the concentration of zinc has to be within the range of 0.00001 mol per dm cube to 0.00005 mol per dm cube. Because the transmittant, in example, the ratio of the intensity of light that has passed through the curvette to the intensity of light when it enters the curvette, approaches 0 when adsorbance is almost reaching infinity. Therefore, the validity of the results cannot be confirmed yet until more experiments with different amounts of sugarcane has taken place. For future research and studies, we would like to find out whether if sugarcane will be able to remove the other metals such as iron, copper, nickel, silver, lead, and cobalt, and if other plants can be also used to remove the zinc instead of sugarcane waste. In conclusion, sugarcane waste is a suitable adsorbent not only because of the fact that they are environmentally friendly. From our experimental results, the adsorbent rate increases with the amount of sugarcane used. If we were able to model the current situation of the zinc levels in the Mekong River, I believe that we should be able to find the most optimal amount of sugarcane waste that should be used to increase efficiency, using the smallest amount of sugarcane waste to remove the most amount of zinc. With the immense amount of sugarcane being wasted daily in countries situated around the Mekong River, the usage of the sugarcane waste to purify the water may be better than the use of other methods. Sugarcane waste can be highly used due to its economic benefits to purify water once we have further information of how to fully utilize the sugarcane waste.